Right, the 2014 relationships paper, tables, equations and graphs, question 2. If the equation of the graph shown below, right, well we can see it has two x-intercepts, one at -4 and one at +2. We always start an equation of a graph with y equals, and if we use the x-intercept method, in the brackets we're going to have x plus 4 and x minus 2. It's always the opposite of the x-intercept. Now we should consider whether there is a number in the front of that, a k-value, whether it's fatter or skinnier than a basic y equals x squared. And to do that we're going to need another point to test. It's not always easy finding another point. I think if we go for this one here, which looks like the point 6 and 40, writing above x and y so we get them the right way around. Now if we substitute this point into that equation, we get 40 for y equals k times 6 plus 4 times 6 minus 2. And you can see that k is just 1. And for question 1 part A, you would assume that it would just be the standard one. So therefore y equals x plus 4, x minus 2. We could also have done it by finding 3 points on the curve. So every graph has a table associated with it. We've got the points -4, 0. We've got the point 2, 0, and we had the point 6, 40 as well. We go into our calculator. We're going into stat. We put in the values from the table. And you can do it slowly as well. I can see it's a quadratic, so we need to choose x squared. And using the calculator model, we get y equals, it's ax squared plus bx plus c, and the calculator gave us some values for that. A is 1, b is 2, and c is -8, so we'll put those into the quadratic form. So a is 1, 1x squared, b was 2, and c was -8. Now if you expand the brackets there, you'll end up with the same equation. X squared, we'll get a -2 and a +4, plus 4x, minus 2x is plus 2x, and we'll get -8 on the end. So either of those would be the correct equation. For what values of x is y negative? So the y values here, if you look at what y values these correspond to, all of these y values down here are negative below the axis. So for example, if x equaled 1 and I put it into the rule, I would get this value. If x equaled 0 and I put it into that rule, the formula we've just found, I'd get that value, which is negative. Any x value, and even in between of course, using decimals, fractions, whenever I substitute any value between -4 and 2, any x value, into the rule we've just found, out will come a negative value for y. So for all x values between -4 and 2, the y value is going to be negative. You want to check the endpoints, but of course when x equals -4, the output is exactly 0. And when x is 2, the output once again is exactly 0, so we want it that way around. Right. Number sequences of this form, q is a constant. If we drew a graph of this, what would q represent on the graph? Well, hopefully you understand that, for example, if we were to substitute x equals 0 into this rule, I would get y equals 0 squared minus 0 plus q, which gives me y equals q. So I can see that when I plot this, x is 0, it's going to cut at some value q. So q represents the y-intercept of the graph. Right. Drawing the graph of y equals x squared minus x on the axis below. Now, whenever I get an equation like that, I like to consider factorising it. Common factor of x, just check with it. We get x squared minus x. Now I know it has two x-intercepts, one at 0 and one at positive 1. So actually what's happening here is it is going below the axis slightly there. It's just very hard to tell from our graph. So what are the coordinates of the vertex, and we have to show our working? Well, as you can see, the two x-intercepts are 0 and 1. So there must be an axis of symmetry halfway between 0 and 1, and that's where that lowest point will be. So it's going to be when x equals a half. Now to find y, we need to substitute into the rule or formula, and we'll get y equals a half squared minus a half. Notice I'm using brackets around the half. Now this is a calculator paper, so you're just allowed to work that out in a calculator if you need to. The answer should be negative a quarter, and remember, negative below the axis slightly. So the vertex would be at a half, negative a quarter. You can check that on a calculator, of course. If we go into the calculator and to answer questions, we could go into graph and we'll put in the formula. We could hit G-solve where the answer to everything is, and of course this is a minimum, so if we hit minimum, I can see that the lowest point is at x equals a half and y equals negative a quarter. So that's a good way to check. Describe in words how this graph compares to the graph above. Right. First thing I'm going to do with this rule is factorise. Common factor of negative 2. X squared minus x. Now just check. We get the negative x squared, and then when I expand and I multiply the two negatives together, it becomes positive 2x. And the nice thing is that what I have in brackets is the original graph. So all we've done is we've multiplied the original graph by negative 2. Now what that's going to do is turn the graph upside down. It will make the original graph upside down. And the maths words for that, if you can remember, is to say reflected in the x-axis. And of course it will be steeper by a factor of 2. Or twice as steep. Right, if the graph from part C1 above was moved 5 units to the right, so we're going that way 5, and then we're going up 15, what would its new equation be? Now there's a lot of ways we can do this. The easiest way, go back to our original equation. Now if we are moving up 15 units, the easiest way is to add 15. And if we want to move it 5 units to the right, then in the brackets we want to use x minus 5 instead of x. So it would be x minus 5 squared right, and then we should do some expanding on that to work out the equation. That's fine if you want to leave it like that if you're not sure. There's quite a bit of expanding involved. expanding x minus 5 means writing the bracket out twice. Running out of space there. X squared, I'm going to get minus 5x is minus 10x. We'll get a plus 25 on the end. Now this is just minus one lot of that. So remembering our expanding, I'll get a minus x, and then we'll get the plus 5. You need to be really careful multiplying that out, which gives me y equals x squared minus 11x. I've used those. 25 and 5 is 30, 45. Right, there is another way you can do it, and that would be to find some points and go to use stat on the calculator and come up with the equation that way. So 5 to the right and 15 up. So it goes through, I'm running out of space here and we need to think about this carefully. It goes through 0, 0 and 1, 0, and I also have the half minus a quarter point. Now each one of those points is moving 5 to the right and 15 up. So let's think about what they would go to. So this point here would go across 5 and up 15. Right, the next point starting at 1, if we go across 5 from 1, it will go to 6 and up 15 from 0. The next one across 5 would be 5.5. We need negative a quarter, and we're going up by 15, so a calculator use on that will give you 14 3/4. Right, now you could go into stat mode on the calculator, enter those 3 points. It's obviously a quadratic, so we'd need to choose quadratic at x squared, and up should come the values for a, b and c. A is 1, B is negative 11, and C is 45. Same rule.